Do you make awesome strip board modules for your DIY synthesizer projects but are bummed about how hard and expensive it is to make great looking front panels for your sonic artwork? In this video, I'll show you how to take your front panels from looking like this to this, and it will only cost you a couple of bucks a panel. I'm Brian from EurorackDIY, and I'm here to share with you how I make inexpensive Eurorack modules that sound and look great. This is part 3 of a series showing the steps I take to make Eurorack modules, in this case a passive multiple. In this video I go through the details of laying out a very simple PC board with the electrical connections necessary for this module. If you haven't already, you might want to go back and watch the first 2 videos in the series to learn more about exactly how this fits into the overall process. Let's get into it. Alright, so now it's time to go ahead and design the board that we're going to use to mount all the jacks on and to electrically connect them. When we built our project in KiCad, we made ourselves a board schematic, and so we'll go ahead and open that now. So the first thing when you want to lay something out is you're going to do a schematic capture of the components that you're going to put onto the board that you're going to do. This is going to be very simple. We're only going to use one component, the component for the jack. And so what we do is you place symbols. That's to place the components, and we click on that. Click on our drawing, and wait for the libraries to load. And now we filter looking for the component in the library, and happen to know it's audio jack 2. In this case, it's 2 because there's 2 conductors on it, and what we're looking for is the audio jack 2 with a switch on the T, on the tip basically. And this is the part that we looked at where we're going to be able to connect the 2 sections together if there's nothing plugged into the input of the second section. So you click OK on that, you get your symbol, and we're going to go ahead and place it. If we hit the C key, we'll get a duplicate of it, so we get another copy of it, place that, copy. Just kind of keep them lined up here, sort of evenly spaced. And now that's half of them, and what we'll go ahead and do is we'll wire together this half that we have now. One good practice to do is for the things you know that aren't going to be connected, is to go ahead and mark them as not connected as such. So this will help with design checking and things like that later. So place a no connection flag, in this case on all the switched inputs of this first bank. And then just go ahead, it's just a matter of going ahead and wiring all the sleeves together. So we'll do that first. Click on the place wire. Draw it out a little bit just to give ourselves a little bit of room. Click, and then you can go down and then line it up exactly with the next switch that you want connected together. In this case, we're going to want to just branch off of here, so we'll click right at that junction of those 2 lines. Switch again. As you see, we get a dot there indicating that the vertical and the horizontal lines are connected in terms of wiring them together. And we'll click again and then connect that to that. And as you can see, we now have them all connected together. We're going to do the same thing with the tip signals. In this case, we'll run it alongside the other ones, the wires that we did for the switch. Click just to give it a place to be out a little bit, and then go ahead and connect them together the same way. Now that we've done that, we can escape, put ourselves back into selection mode. Go ahead and copy the selection, and then do Control C to copy it into our buffer, and Control V to paste it. And now we have an exact duplicate of the wiring that we have for the second set of jacks that we're going to have. Go ahead and click to place that, keeping things nicely lined up. Now on the board, we want all of the sleeves wired together. So we're going to go back to wire mode, and we'll just select a junction here of one of the sleeves, come down a ways, click to keep it down on the bottom, and then hook it back into the sleeves on this side. And then the other thing that we said we want to do is we want to connect the input, which will be, we'll treat this one as the input, and you can see when we number them, they'll be numbered 1 through 8, and we'll number the this portion where it says J question mark. You can assign reference designators to it, and we'll assign the designators 1 through 8, and essentially in this order: 1, 2, 3, 4, 5, 6, 7, 8, and 5 will represent the second input, the bottom input. I'm going to go ahead and remove this no connect, and just select it and hit delete. And what we said we wanted to do with this is connect it to the tips in the first bank, so that if nothing's plugged into it, it will switch this onto the tip signal for these 3 here. So if you plug a jack into just this, or if you plug a patch cable into just this jack, it will then be wired to these jacks and then also this one, because what we're going to do is go ahead and get back into wire mode and connect this tip switch here. Again, give ourselves some room and a place to draw onto the bus of tips on the second one. So we can see that now all of these tips are connected together plus this switch. And so when there's nothing plugged into this jack, all of these tips will be connected together. So you can now put outputs into these particular jacks. And that is pretty much it for the schematic that we need to create this board. So we'll go ahead and save that. And the next thing that we're going to want to do is get the footprint for this that we're going to put onto the board. And the stock footprint that comes in KiCad isn't quite what I'm looking for, because I want to line up the center of the jacks with along a guideline that we're going to draw as we draw the board, so that we can keep everything nicely aligned and straight and lined up then with the panel that we've made using the same measurements for it. So once again, we'll get into the footprint editor. Click on that. And when that comes up, we're going to go ahead and filter. And I happen to know that the particular jacks that we're using, these guys right here, are Thonkiconn jacks, or what you can usually find them as. And so it happens to be in KiCad. It also has that as the name in it. It's got a bit longer. It's the manufacturer name, Kingpu. But this is the one that we want, basically, and just in its notes it says Thonk, and so that's why we can search for it. So we're going to go ahead and edit this particular one. Actually, before we edit it, let's go ahead and create ourselves a library, because we know, again, we're going to want our own library for us. Just like we did a graphics library in this case. Let's call it audio local. And then we'll, and again, just for this project, although maybe I would want to have it for the global project, and we have to wait while it updates the footprint libraries. And there, once that's done, get back to our footprint editor. Now, it's probably really hard to see on the screen here, but there's a light or a dark blue line going through the field here, and that's the center of the footprint. And what I want is I want the center of these circles here on the center of that footprint. So I'm going to go ahead and select all the pieces to this component, and then click and hold, drag on it to move them, and then go ahead and just zoom in as far as we can go and still see the circles with everything selected. And looking sort of at the flat spots on the top and bottoms, the top, bottoms, and sides of the circle, and then just trying to get that sort of lined up with that blue with the blue crosshairs that go across the drawing. And that's probably close enough. This way, when everything's flipped and everything else, that they'll all match up. So that's one of the things we want to do with the footprint. The other thing is that there's a lot of stuff on the silk screen, and for this board, for a lot of boards, sometimes it's good to have the silk screen stuff, and you want to be a little careful about what you have on your silk screens when you look at the board, so that it's good reference information when you're looking at a board. But this is just, again, really simple, and so we don't want all these silk screen pieces. So what we want to do is this reference, just like on the other board, we moved it off of the silk screen because on the panel, because we didn't want to see these reference numbers on the silk screen. I'm not looking for them on this one either. So we're going to go ahead and move this to be on Drawings User. And as you can see, all these other turquoise pieces here are also silk screen things. And so I'm just going to go through and select them all and hit the delete key to delete each of these pieces. And then in some cases it overlaps with another line, so when you click on it, you get something to clarify the selection. We will obviously want the one that's on the silk screen, so we'll select that. Again, silk screen, delete. Front silk screen, hit the delete key. This is in 2 segments. Front silk screen, hit delete. Silk screen, then delete. And this last one, and delete that. And then also this circle here, we're going to go ahead and delete that. There's 2 gray lines. Oh, we didn't get that deleted. Okay. There's 2 different shades of gray lines, and basically one set of them are the user drawings, and then the other one is the front fab. And actually, I guess there's 3: the front fab, and then the last set is this front courtyard. And so as you can see, as we select visibility of them all, they come and go. The courtyard can be interesting on parts because it's sort of the area you have to, when you're laying them out, that they have to match up against each other. As we lay this out, we're going to put them a little bit closer than the courtyard. It just happens to be, I know, because I physically have the jacks in hand, that I can place them closer on the board than what they all are. All right, so with that, we basically have everything the way we want it to be. So we can go ahead and save this our edited footprint as a new name and in the library we created. I'm just going to go ahead and add the word centered on here so that we know we have something to look for, and then we'll filter in the library for local, and there's our audio local for the stuff we have there, and we go ahead and save that. And that's basically all we need of the footprint editor. So the next thing that we are going to do is export assign the PCB footprint. So what we have to do is, now we have these schematic symbols for all the jacks. We actually have to assign that particular footprint to these particular symbols on the schematic. And there's a tool for that in KiCad. This one that has basically a footprint, or a schematic symbol to a footprint on it. And the first thing we need to do before we do that is we need to annotate the schematic, and we need to fill in, which means basically fill in all these question marks on the jacks. The thing we're going to do here is, as I said, we want to number them 1 through 8 going down in this order, and so we want this one selected here, sort components by X position, where you can see it draws the ordering line exactly like we want it. So we can go ahead and say annotate, and sure enough, it's got them all annotated. Let's just continue to look at that before we move on to the other. But it's got them all annotated now, 1 through 8, in the order we want them to. And that way, when we place the footprints on the board, we'll know where we need to put them. So now we'll switch to the Assign Footprints editor. Bring that in here. And as you can see, we have our 8 jacks here, and we need to find a footprint for them. There's various filters up here that you can use when you're doing more complex things like other kinds of components and stuff. This particular one is just looking for it's looking for it as a search box. We know that we type the word centered onto it, and sure enough, this is our, this is the one that we created that was centered. We can select all 8 of these, click the first one and then shift click on the 8th one, and then double click on the footprint we want them all to have. And now it's associated all of them with this particular footprint. So we want to apply this, save the schematic and continue, and then OK. And one last thing that's good to do is to do the design rules checker and get used to, or the electrical rules checker, and get used to that, the output of that. So if we go ahead and perform that at this point and run an electrical rules checker against it, just with the default options and stuff, we run it and we see it's finished and there are no violations of the rules at this point. This is a good habit to be in when designing any boards, and so I recommend doing that when you do it. So now that we've got all of that done, we're ready to go start our layout. And so in this case, again, we're going to run PCB new, or the PCB layout tool of KiCad. And it doesn't exist yet, so yes, of course, we would like to create it. And we get it in a familiar view to what we had last time. As we lay things out, we connect the various pads on the components with tracks. And so one of the first things I want to do here is I'm going to use a track width that's wider than we typically get to use on a board, because we have a lot of room on this board. It's simple and there's not a lot of stuff to do with it. So if we go to board setup for our new board, and then here we see that there's a selection tracks and vias, and you can set various kinds of parametrics about the things that you'll place on the board and stuff. Tracks being the easiest. It's the trace, the route, the trace that connects the components together, or the pads together on the components. In this case, we're going to add one, and then you get to say how wide they are, and we're going to do a full 1 millimeter trace width. So once we have a track of that, we can say OK. And then, as you can see here, when you're laying out the board, you can select, you have various hot menus here, or whatever, that you can select the different tracks, vias, and what have you that you've defined. So in this case, we're going to go ahead and select that so that when we do get around to laying out the tracks, we have the right size. Also, just like on the panel layout, we're going to start off with our grid at 0.1 millimeters. The things that we're placing on here, I guess they're in whole millimeters, but actually, I'm going to go ahead and do that now. So we go ahead and place them in whole millimeters, and then we can actually go to that as we define the layouts for it. And then also, I want to once again set the grid 0 point up here in the corner, and again, watching, I want to put it, I think, in this particular case at 30-30. And so watching down on the bottom of the screen where the X and the Y is, and get it right at 30-30, and hit that there. And then I'm also going to hit the space bar to set up my relative, the dx/dy, from that point too, so that we can watch it as we draw things. Now what we need to do is we need to go back here, and we're going to use these spacings, the 14, 28, 42. This is why I wrote them down, just because I wanted to know how far they were. And we're going to start out by laying out guidelines from the top and then moving down, and just so we can kind of check our work and know that this last one needs to be, the center for this last jack will be 100 millimeters from the top. And we're going to do this the same way as on the other one, or as on our panel, to lay things out. Is we're going to do them with user drawings first to figure out where everything is. And we're just going to draw a vertical line down to represent all that. But first, just draw one line here horizontally to make a tick mark where we're going to start this process. And again, you can hold the control to constrain where this line goes, and double click to terminate the line and not continue to draw others. And now we'll just start moving down, and so we'll create a line that goes down 14. This is quite a bit easier doing this on whole millimeters, and this is all we need at this point. So it's it's important to pay attention to your grid size and how much you need to lay things out. So we go down 14, double click. That's the second one. Again, I'm watching the lower left-hand corner, not the very lowest, but you can see there's the information about the line segment that we're drawing. And now we're at 14. If you look at the dx, dy, or the dy, we're at 28, which corresponds, this corresponds to these numbers here, and that's how I'm checking that work. So get it lined up to 14 millimeters and put another tick mark, double click, and that's 3. And so now we'll place our fourth jack 14 millimeters down, and that's at 42. So now there's the gap of 16 millimeters that we put between the two banks of jacks. So we'll go ahead and draw another segment that goes 16 millimeters down. And out, and that's again at dy 58 millimeters, just checking against our other work here. And now we're back to spacing of 14 millimeters. That's for the next 3. That's 1, 2, 3, and the fourth one. And getting that to 14 millimeters on the bottom. Again, if we look at the dx/dy, we notice that in the y direction we're now at 100 millimeters, which is what we calculated out when we did them all originally. And that's where we want, each of these tick marks represents where we're going to want to align the center of each of the jacks. Get out of drawing mode, and okay, now that we have all of this laid out, we can go ahead and import the footprints and their association, and it will have the wired net list and show us where we need to draw traces between the footprints after we lay them out. And so we're going to import those from the schematic. It's important that you have loaded the schematic from the KiCad window, from the project itself. Have the project itself that's open for the board to be able to do this. Anyway, to have them associated together. And if you're having problems in your PCB New, you just need to go back to the KiCad main window, open the project for the board specifically, and then navigate your way back here. So clicking on this, we see that the update PCB from schematic, we're going to keep the existing simple to footprint association. If there were any that were here already, you can do this multiple times as you develop the schematic and the board and go back and forth between the two. Because this is a simple board, we pretty much nailed the schematic the first time on as we did it. It's all correct probably at this point. And so this time it's going to go ahead and bring all of the footprints in because they don't yet exist on the layout here. And go ahead and say update PCB to bring them in, close, and then now it's a little bit odd, but they're now connected to your cursor, so you need to click to place them somewhere, and then we're going to go ahead and lay them out. As you can see, they're all numbered J1, 2, 3, 4, 5, 6, 7, 8. If they weren't, we'd have a hard time knowing which one was supposed to go to which and keeping track of that special one, the second input, and things like that. So we're going to start at the top with the first jack. Now, as I mentioned earlier, to get the grouping and the spacing correct on these, we're going to turn the top set of jacks upside down from how they're drawn here. As you can see, it's closer from the center of the jack to this conductor in this direction than it is in the other direction, so we don't have as much wasted space, if you will, at the top of the board. So go ahead and select the footprint, the whole footprint for it. Now you can see as we can drag it around, and even as I'm holding the mouse button down, the left mouse button down, and dragging it, I can type the R key to rotate it into the position we want. We'll get it close to where we want it. You can see there's a target there in the middle as I have it selected, and now we can see it's a little bit off from where we want it, so I can select it again and keep moving it, and then it's probably fairly hard to see on the screen, but that white target reticule that's in the middle of the jack, the circle here that represents where the plug actually goes in. We're going to line that up exactly at the crosshairs on the guidelines that we drew out. And that's the first one placed. And so now we're just going to do the same thing with the other 3 that go on the top. So grab it, rotate, get it close, zoom in, and go ahead and use the crosshairs now to line it up exactly at that cross point. Do that with 3 and then 4 put up here, so make sure that you're looking at the numbers on there and don't just grab the next one in the pattern. Now we're going to do the bottom half. These don't get rotated, so all we have to do with these is simply drag them to their final position and get them aligned using the crosshairs. 5 and 6. Seven. One thing too, while I have them still apart here a little bit, is you'll notice there's these white lines connecting the pad from one to the pad from the other, and they're kind of smart lines. It's, if you were wiring it together, it's sort of the closest next connector where those would go. So as I grab these and I move them, you'll see that it moves to connected to different pads on the different ones, because those are all electrically connected the same way. So we can go ahead and put this here. The reason I pointed out there is because when we get them all lined up, they're all sitting on top of each other, and so they're not the easiest to see where they are. They call this the rat's nest, and as you're doing the wiring of the traces on the board, you need to be able to see those to see where they go to. You'll also get some indicators in terms of like what gets highlighted as you do this. Okay, again, I mentioned earlier that it's good to check, make sure that our track width is set to 1.0. We're now ready to connect up all of the various pads on the footprints that we have. And I'm going to start with the sleeves, this S. They're all connected together on all 8 of them, as we'll see. And now we're going to use the Route Tracks tool here to do this. And one of the things to note about this is that when you start routing tracks, you click on it and it will drag it around, but it will try to sort of do a smart job of moving them around as to where you want. I like to try to keep things kind of neat, and then also when you lay out boards, you don't want right angles, and so I'm going to do this in a way that I can avoid the right angles without too much grief in the ways that KiCad is going to try to connect these together. So that's why I'm going to go up from the bottom on the sleeve connections, and so just click on the pad, one of the pads that you want to connect, and then start moving it up basically along the route moving your cursor along the route you want it to take ultimately. As you can see, this has nice 45-degree angles as we connect it together. So we just keep working our way up. Oops, and you see if you miss, right, if you miss like even down here at the bottom, it'll start to take a different path, and then like that's not what we want. So we can kind of go back and trace our way and sort of coax it into connecting it the way we want. Oh, and then this is where we go from the bottom to the top, and because we flip them up, this particular one is nice and close. We just get to do one nice straight one right here. And then back to Moving it around this way, checking to make sure that they all have nice 45-degree angles as we do this. Oops. Here again, it probably helps to be zoomed in a little bit closer because the movement maybe is not quite so dynamic. And with that, we have all of the sleeves tied together. If you see, if we click on this one, there are no more pads that are highlighted that we need to connect together. So we've got them all connected together. So now we're going to do the same thing with the tips. As you can see, starting with this one here on the bottom, it's got the thin white rat's nest line out. We'll go up the other side for these. And then we also want to make sure, again, that we get nice 45-degree angles into everything. Now this is the fifth one, the second input. So we know that this TN, which is the switch for it, we know that that is also has connection. And if we look closely, zoom in, you can see the rat's nest line going here. It looks like it might be going to these other ones, but actually it's going up higher. So it's going all the way to the tip of the previous one. So as we click on it, we can, again, now we get the nice indicator as to the highlighting of the pad that it's the next pad up that it's supposed to go to. And if you look, it's even, you know, beyond that, the other pads that we're going to route to. So now we just go ahead and route all the tips of the top set of jacks together. Again, paying attention to try to and these are going to work better if we go downwards in terms of keeping them at 45-degree angles like that. And it looks like that's all of them. We go ahead and get out of routing mode. And at this point, what we can do is we can go ahead and check to make sure that we have everything wired up correctly. And so there's a design rules checker, and we can run that, run the DRC, and we'll get some warnings that we expected. And that's on the courtyards overlapping, and you notice there's like little red arrows on here. I guess if we can zoom in on one of those. There's red arrows where they show that they're overlapping. It's the outline of the audio jacks. As I mentioned earlier, I know that they're going to overlap. It's okay. They all fit on there. But let's make sure that that's the only problems that we have are that. And it is, there are no unconnected items, which is the most important thing. So everything in the rat's nest is connected together, meaning that we now match our schematic that we drew, which we believe is correct. We can go ahead and get rid of the markers so that they don't clutter up our drawing anymore. And then the last thing that we have to do is draw the outline for the board, now that we have everything connected up. And it's going to be just like for the faceplate, it's going to be an edge cut. We're going to draw that with a line in. And just to make things a little bit easier on ourselves, we'll go ahead and go to a grid size of 0.5. What we're going to want to do, if you remember, the width of the board, the entire board is 9.8 millimeters. I'm just checking really quick here. If we look, the actual width of the keep out area, this is 10 millimeters. And so if we made our board 10 millimeters, it'd actually be wider than the other modules, and it'd bump into modules next to it and such. And since this is only the only part of the board that we really need is the place where we're going to solder things in, and then the the actual traces themselves, and then that all stays nice and tidy and very close in. We don't need to have it that full width. We'll make it, say, make it about as wide as we can afford to, so we'll make it 9 millimeters. And again, top and bottom, there's not a lot of room between the rails on there either, and so we don't want to get too close to those. So what I'm going to do is from the top here, I can see pretty easily, especially with this grid placement, where the center is, and I'll just go ahead and draw a line here, again watching in the lower left hand corner for the length to make sure, and we'll do 4.5, so we'll do 9 millimeters across, which will keep it inside the 9.8 of the module itself, but make it as wide and have as much material as possible. And we'll do the same thing in the other direction, just so that we have it 4.5 millimeters from each center. And then from there we can take from the corner and zoom out and zoom back in down to the bottom, and hold down Control to make sure that we keep it all nicely vertical, the line vertical, and we'll click it here to put a corner, come over here, make it, in this case we know we want to make it a full 9 millimeters all the way across the bottom so it'll line up, and come back and back up at the top and double click or hit escape if you don't quite get the double click to close the edge cut and the actual outline of the board. One more thing, as I did on the front panel, is going to go ahead and put a version number and a date on it, and maybe you can even write your own name, maybe write the name of the board or whatever on it and stuff too, just so that you know where the board goes. In this case, I'm just going to put text on the front silk screen layer. Again, select front silk screen and text. Click once to get the dialog for what you want to put on there, and then I give them a version number 1.0, a rough date, December 2020. And I know that I'm going to want it a little bit smaller again, just so it fits on the board nicely. So I'm going to change the width and height of the characters to 0.75. And there we have it. And I'll just rotate this so that it fits the long ways on the board, and make sure that I put it inside the lines that define the edge cuts on the board. And that is everything that we need for our board at this point. So go ahead and save the file. Thanks for watching, and I hope the information I shared here was useful. It will help keep me motivated to make more of these videos if I know people are watching them. You can help me out by leaving a comment or a like and sharing with friends who might also be interested. Also, please be sure to subscribe so you won't miss any future videos I make.